First we'll study concepts of number theory. So different types of numbers can be represented in the form of set. 4.5 does not belong to integer, remember this. What is a prime number? A number which is divisible by itself and 1. This is called as prime factorization, or we call it as canonical representation. Important questions for board exam also you'll be learning, and you'll be learning Welcome to the session, dear students. In my last class, we have studied important chapter, that is coordination system in a plane. So now in today's session, I'll be starting with the important chapter, that is number theory. In algebra, this is one of the interesting chapter. First we'll study concepts of number theory. In today's class, I'm going to teach you number systems, different types of number systems and examples, and we'll also see how to factorize and how to represent a number in canonical form. So now in today's class, the very first concept is number system. So different types of numbers can be represented in the form of set. Set means what? Collection of different elements. Now natural numbers. The first set what we are discussing is natural numbers. Natural numbers are denoted by letter N. Natural numbers starts with 1. We also call them as counting numbers. Number 1, 2, 3, 4, so on, they are all natural numbers. Counting numbers, numbers starting from 1. If I ask you to start count the strength of the class, so 1, 2, 3, like that you will go on numbering. So 1, 2, 3, counting numbers. Natural numbers start from 1. They are all positive numbers. And if I ask you whether 2.5 belongs to natural numbers, no, it does not belongs to. How to read this symbol? This symbol is read as what? Belongs to. Belongs to. So if I ask 97, does 97 belongs to natural numbers? Yes. So all the counting numbers. But 0 does not belong to natural number. Decimals does not belong to natural numbers. Fractions like 2 by 3, rational numbers are not natural numbers. Now first, what are natural numbers? Numbers of the form 1, 2, 3 till infinity. So the first natural number is 1. Natural number starts from 1. So now first system is studied. Counting numbers 1, 2, 3, 4, 5 are natural numbers. They are also called as positive integers. We can also call them as positive integers. Then we have whole numbers. The second important set is whole numbers. Along with natural numbers, if you include 0, if you include what? 0, we call them as whole numbers. So whole numbers, W stands for whole numbers, numbers starting from 0, 1, 2, 3, so on. Means natural numbers means along with natural numbers, if you include 0, that is whole number. Whole number starts with what? 0. 0, 1, 2, 3, so on till infinity, we call them as whole numbers. So now you know what are natural numbers, now you know what are whole numbers. Then other system, number system, that is integers. So integers, set of integers means all positive natural numbers 1, 2, 3 till infinity, 0 and minus 1, minus 2, minus 3 till infinity. So this set represent integers. We denote integers using letter Z. Z stands for, capital Z stands for integers. Here 0, 1, 2, 3, 4, 5, 6, so on, and minus 1, minus 2, minus 3, so on till infinity. And here we can divide them again into positive integers, negative integers. So positive integers means positive numbers 1, 2, 3, 4 till infinity, we call them as what? Positive integers. And negative numbers minus 1, minus 2, minus 3, minus 4 till infinity, we call them as what? Negative integers. An interesting fact is 0 is neither positive nor negative. 0 belongs to Z, and 0 is not positive, 0 is not negative. So 0 does not belong to Z. We cannot say it's positive or negative. It's neither positive nor negative. 0 is an integer. It's neither positive nor negative. So now all of you know what are integers. What are integers? Numbers starting from 0, 1, 2, 3, so on, and negative numbers including 0. But decimals are not integers. If I ask you 4.5 does not belong to integer, remember this. Without the complete knowledge of number system, you cannot understand theorems and problems. Now going ahead, we'll study other number system, and also we say odd and even integers. Odd integers means odd numbers 1, 3, 5, and also you can take even integers 2, 4, 6, negative 2, minus 2, minus 4, these are all even integers. And we can write integers, we can write subset as positive numbers, positive integers, negative integers, and odd integers, even integers, like that. So now set integers, set natural numbers, set whole numbers. What are natural numbers? Natural numbers are the numbers starting from 1, 2, 3, counting numbers. Whole numbers means what? All the natural numbers including 0. 0, 1, 2, 3 are whole numbers. Integers, positive numbers 1, 2, 3, 4, 5, so on. Negative numbers minus 1, minus 2, minus 3, so on. And 0. 0 is neither positive nor negative, but it is an integer. And other than that, we have important concept called prime numbers. What are prime numbers? All integers, say p greater than 1 is said to be, say if I take an integer p greater than 1 is said to be a prime number. An integer p greater than 1 is said to be an integer p greater than 1 is said to be prime number if it has no divisor except 1 and itself. It should have integer except 1 and itself, no other divisors. For example, 7. You know 7 is divisible by 1 and itself. There is no other factor for 7. 7 ಅನ್ನೋದು 1 ಇಂದ ಡಿವೈಡ್ ಆಗುತ್ತೆ, 7 ಇಂದ ಡಿವೈಡ್ ಆಗುತ್ತೆ. ಬೇರೆ ಯಾವ ನಂಬರು 7ನ ಡಿವೈಡ್ ಮಾಡಲ್ಲ. ಸೊ ಆದ್ದರಿಂದ ಇದಕ್ಕೆ ಬೇರೆ ಡಿವೈಸರ್ಸ್ ಇಲ್ಲ. ಸೊ ಅದಕ್ಕೆ ಇದನ್ನೇನಂತ ಕರಿತೀವಿ? ಪ್ರೈಮ್ ನಂಬರ್ ಅಂತ ಕರಿತೀವಿ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್, ಇಫ್ ಐ ಟೇಕ್ 8 is not a prime number because it has factor 1, it has factor 2, because 8 is divisible by 2, I can write 2 4s, it has factor 4 and has itself. Not only itself and 1, it has other factors also. So therefore 8 is not a prime number. What is a prime number? A number which is divisible by itself and 1, and it should not be divisible by any other factor other than 1 and itself. A number is said to be a prime number if it is divisible by 1 and itself. No other number should be able to divide that. So we say an integer p greater than 1, that number should be greater than 1, is said to be a prime number if it has no other divisors. It should not have any other device other than 1 and itself. Means it should be divisible by 1 and itself. ಬೇರೆ ಯಾವ ನಂಬರು ಅದನ್ನು ಡಿವೈಡ್ ಮಾಡಲಿಕ್ಕೆ ಆಗಬಾರ್ದು. ಅದನ್ನು ಏನಂತ ಕರಿತೀವಿ? ಪ್ರೈಮ್ ನಂಬರ್. Again I am repeating, your basics should be strong. ಈ ಚಾಪ್ಟರಲ್ಲಿ ಬೇಸಿಕ್ಸ್ ಅಂದರೆ ಏನಪ್ಪ? ನಂಬರ್ ಸಿಸ್ಟಮ್ಮು. ಆ್ಯಂಡ್ ಇಫ್ ಐ ಗಿವ್ ಯು ಎ ನಂಬರ್, ಯು ಶುಡ್ ಬಿ ಏಬಲ್ ಟು ಡಿಸೈಡ್ ವೆದರ್ ಇಟ್ಸ್ ಇಂಟೀಜರ್, ನ್ಯಾಚುರಲ್ ನಂಬರ್, ಈವನ್ ನಂಬರ್, ಆಡ್ ನಂಬರ್, ಆರ್ ಇಟ್ಸ್ ಎ ಪ್ರೈಮ್ ನಂಬರ್, ಕಾಂಪೋಸಿಟ್ ನಂಬರ್. ಲೈಕ್ ದಟ್, ಇಫ್ ಯು ಆರ್ ಏಬಲ್ ಟು ಡಿಸೈಡ್ which number system the given number belongs to, then you can solve the problems. So now first I told you what is a prime number. An integer p greater than 1 is said to be a prime number if it has no other divisor except 1 and itself. It do not have any other divisor other than itself and 1. We have two important concepts. One, 2 is the only even prime number. Rest all other prime numbers are odd prime numbers, but only 2 is even prime number. It is even because it is divisible by 2, and it is a prime number because no other number other than itself and 1 can divide. 2 another prime number. Aduk factors yavadu? 2 and 1. No other number can divide. So it is divisible by only itself and 1. Therefore it is prime number, but it is the only even prime number. What is the only even prime number? 2. And prime numbers are infinity. How many prime numbers are there? We have many. So if you go on writing, 3 is an even number, 3 is a prime number, 7 is a prime number, 11 is a prime number, like that you can go on, infinite prime numbers. Then we have composite numbers, opposite to prime numbers. What is a composite number? An integer which is not a prime number, means which has divisor other than itself and 1. Which is not a prime number means what? It should have a divisor other than 1 and itself. It is composite number. For example, 8 is a composite number because it has divisor other than 1 and itself. 8 is divisible by 2, 4, so like that. Now composite number which is not a prime number is called as composite number. Which is not a prime number means what? Composite number means a number which is not a prime number is composite number. Means what? Means it's a number which has divisor other than 1 and itself. 1 ಮತ್ತೆ itself ಅಲ್ಲದೆ ಬೇರೆ ಡಿವೈಸರ್ಸು ಇರುತ್ತೆ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ 15 is not a prime number, it's a composite number. Why? Because it has divisor called 5, it has divisor called 3, and it has divisor 1 and 15. Other than 1 and 15, it has other two divisors, therefore it is composite. If a number is not prime number, it is composite number. What is composite number? Composite number is a number which has divisor other than 1 and itself. Now, fundamental theorem of arithmetic. So before we start this, First, let us recollect. Today I started the class with number theory chapter. In that, first I taught you number system. So first I taught you natural numbers. What are natural numbers? Numbers starting from 1 to, and then I taught you whole numbers. What are whole numbers? Numbers starting from 0, 1. And then I taught you integers. What are integers? Positive numbers and negative numbers till infinity. And we also have rational numbers, numbers of the form p by q, where p and q are integers and q is not equal to 0. Irrational numbers, a number which does not belong, real numbers which are not rational, we call them as irrational. So further we will discuss this also. But for this class, so I want you to become thorough with 4 number system: natural numbers, whole numbers, integers, and positive and negative integers. Now we will go to the 7th concept, that is fundamental theorem of arithmetic. What is the fundamental theorem of arithmetic? Simple. If I give you any number, any composite number, what is meant by composite number? A number which has factor other than 1 and itself. What is composite number? A number, if it is not a prime number, we call it as what? Composite number. When I give you composite number, any composite number, you can express it as product of prime numbers. You can express it as what? Product of prime numbers. For example, I will take simple number, say 20. 20 I can express it as product of prime numbers. So can I write it as 20 can be written as 2 into 5. What is 2 to the 4? 4 5 is 20. 2 is a prime number. 2 is a prime number. 5 is a prime number. Or I will write 2 into 2 square into 5. Or if I take 35, 35 is a composite number because it has factor other than itself and 1. Can I write it as 5 into 7? What is 5? Prime number. What is 7? Prime number. What is 35? Composite number. This composite number, I am writing it as product of prime numbers. Product of what? Prime numbers. P1 first prime number 5, P2 second prime number 7. So any composite number can be expressed as product of primes, and their decomposition is unique. Means the splitting, you will get only one different form. So this is one form, and you cannot have more than this. So P1 power alpha 1, P2 power alpha 2, like that. So example I wrote here 35. 35 can be written as 5 power 1, 7 power 1. This is the only form. You can rearrange, that's it. And if I give 20, you can write it as 2 into 5, 2 square into 5. 2 is a prime number, 5 is a prime number. This is the unique form. The decomposition is unique. You will not have any other form. You will not have any other numbers or other arrangement. 5 into 2 power 2 or 2 power, always will write in ascending order. The bases should be in ascending order, that's it. Hope all of you got it. This is called as prime factorization, or we call it as canonical representation. Prime factorization or canonical representation, both are same, means are writing a composite number as product of prime numbers. Writing a composite number as product of prime numbers is called as what? Prime factorization representation, or we say canonical representation. Now once if I ask you to write in canonical representation, what you should do? Write them as product of prime numbers. Write them as product of prime numbers. For example, I'll ask you to write, I'll give you a composite number, I'll ask you to write as product of prime numbers. Say I'll take 50. So can I write 50 as 5 tens are? But 10 is not a prime number. I want it. So now 5 into 5, 25 into 2. Can I write? Because 5 is what? Prime number. Further 5 power 2, 2 power 1. Or always write first lower prime number, then 2 power 1 into 5 square. This is a canonical representation. What is canonical representation? Representing a composite number as product. Product means what? Multiplication. We read this as product of 2 power 1 into 5 power 2. So representing a composite number as product of prime numbers is called as canonical representation. To do this, we can do prime factorization. We can do what? Prime factorization. How to do that? Now, if I give any number, say I will take 120. First you start dividing it. First you start dividing with least prime number if it is divisible. Is it divisible by 2? 2 is the least prime number, even prime number. Even prime number. The first prime number in positive numbers is 2. I will start with 2. 2 into 60. Further this is divisible by 2. 2 into 30. Further it is divisible by 2. 2 into 15. Quotients I am writing. This is not divisible by 2. What is the next prime number after 2? What are the prime numbers? 2, 3, 5, 7. So now next prime number is 3. I will take 3. 3, 5s are 15 and 5, 1s are 5. Now I spread this. Now I can write 120, whatever 120 I give, write it as 2 into, one of the number is 2, other number is 3 and other number is 5. 2 how many times? 1, 2, 3, 3 times, 2 cube. Into 3 how many times? Power 1, 5 power 1. This is the canonical form. I hope all of you understood how to do. Start with the prime numbers. So 2 is the first prime number which divides this. I'll go on, but when I come to 15, 15 is not divisible by 2. What is the next prime number? 3. Try with 3. Yes, it is divisible. 3 5s are. 5 is not divisible by 2 and 3. Try next prime number 5. 5 1s are. When you will get 1, stop the process. And 2, how many 2s we have? 3. 2 power 3. How many 3s we have? 1. How many 5s we have? So 2 cube is 8. 8 into 3 into 5. 8 into 3 into 5. You multiply, you will get same. Or 5 2s are 10. Sorry, 8 into 2 into, you multiply this. So if you simplify, this is 8, this is 3, this is 5, this is 24 5s are. What is 24 5s are? 120. So writing this is called as canonical form. So now we have to solve problems based on canonical form. So the very next concept what we are discussing is, if I give you a number, how many divisors are there? Number of divisors. What is the sum of the divisors? So suppose if I give simple number, I will take a simple number. Before we go to the process, let us take a simple number. I will take a simple number, say I will take 10. What are the factors for 10? 1 is a factor because 1 is factor for any number. 1 divides any number. 2 is a factor because 2 divides 10. 3 does not divide. 5 divides and 10 divides. So total we have 1, 2, 3, 4 factors. How many factors for 10? 4 factors. 1 is itself. 1 is 1. Other than 1 and 2, it has 2 extra factors. Number is less, so I can start counting the factors. If I give more, so 12 if I ask. What are the factors for 12? 1 is a factor, 2 is a factor, 3 is a factor because 3 4s are. 4 is a factor, 4 3s are. 5 is not a factor because 5 cannot divide. 6 is a factor because 6 1s are, 6 2s are. Because 6 can divide. And 12 is a factor. So we have 1, 2, 3, 4, 5, 6 factors for this. Other than 1 and itself, we have 4 different factors other than 1 and itself. If you take 1 and like this. But if I give a number like this, 9, 6, 4, 8, 2, how many factors are there for this? So we cannot sit and count 1, 2, 3, 4, other count madadakagalla. So for that we need to write in canonical form. So that canonical form will be helpful for you to calculate number of divisors and sum of divisors. In my next class, I have to deal with sum of divisors and number of divisors. For that, first you should know how to represent a number in canonical form. What is meant by canonical form? Writing the composite number as product of prime numbers. Writing the composite numbers as product of prime numbers is called as canonical form. That form we just now we have discussed, and it is decomposition is unique. Means what? One process or one form will get. We will not have more than one form. So one set of prime factors will get. So we have to represent it, and then we can go for sum of divisors, number of divisors. What is meant by a divisor? Which will divide by leaving remainder as 0, or which do not have any remainder other than 0. So now divisor means which will divide the given number. For the 10, what are the divisors? 2 is a divisor, 3 is not a divisor. First you should know what is divisor. It's very important. Yes, we'll go to the problems, you will understand the steps, you will know the procedure, but first the basics. Divisor. What is meant by divisor? What is meant by divisor? A number which can divide the given number is a divisor. Now I'll ask you, what are the divisors for 30? What are the divisors for 30? Yes, obviously 1 is divisor for any number. Then 2 can do divide. Yes, 2 divides 30. 2 1s are 2 15s. So 2 is a divisor. Is 3? 3 is a divisor for 30. Yes, 3 1s are 3 10s. 3 is also a divisor. Do you agree? And what about 4? Is 4 a divisor? Is 4 a divisor? 30 divided by 4. Does 4 divides? No, you will get decimal. 4 7s are 28. Point barutte. So 7.5. 28, 20 means 7.5. Decimal barbardo. So means if I really divide with 4, I'll get a remainder. 4 7s are 28 and remainder is 2. We should get remainder 0. So we will not get remainder 0. So 4 is not a divisor. So 4 is not a divisor. What about 5? Yes, 5 divides. 30 divided by 5. 5 1s are 5 6 are. So 5 will divide 30. 5 is a divisor. What about 10? 10 is a divisor. 10 1s are 10 3s are. What about any other number? 15. 15 1s are 15 2s are. 15 is a divisor. Then any other number? 20 is not a divisor. 25 is not a divisor. 30 itself is a divisor. 100 itself is always divisors. Other than that, I could select these many numbers: 2, 3, 5, 10, 15. One more interesting fact: a divisor cannot exceed the given number. So I cannot have divisors more than 30. For 30, divisor cannot be more than 30. 31, 33, 40, 60 cannot divide. Divisor is always smaller number or itself. Now this is the first concept you should be thorough with. Divisor andre ಏನು ಅಂತ ಗೊತ್ತಿರಬೇಕು. ಕೊಟ್ಟಿರೋ ನಂಬರ್ನ ಡಿವೈಡ್ ಮಾಡಿದ್ರೆ ರಿಮೈಂಡರ್ ಇಲ್ಲದೆ ಅಥವಾ ರಿಮೈಂಡರ್ 0 ಕೊಡಬೇಕು, ಅದನ್ನು ಡಿವೈಸರ್ ಅಂತೀವಿ. 30 ಡಿವೈಸರ್ಸ್ ಯಾವುದು? 2, because 2 divides 30, 3 divides 30, 5 divides 30. These are the divisors. First you should be thorough with what is a divisor. Now I think you know what is a divisor. After you know what is a divisor, then we go for canonical forms. Now my next class I want to teach you people number of divisors and sum of divisors, T of n, S of n. For that, first I want people to become thorough with number system. What are natural numbers? Natural numbers are the numbers starting from 1, 1, 2, 3, so on till infinity. Counting numbers antivu. What are whole numbers? All natural numbers are whole numbers, including 0. Whole numbers means what? 0, 1, 2, 3, so on. After that, I taught you what are integers. Now, the very next concept is canonical form. Means any composite number. What is composite number? A number which is not a prime number is composite number. What is composite number? A number, if it is not a prime number, then it is a composite number. What is prime number? An integer p greater than 1. Integer p greater than 1 is said to be a prime number if it is divisible by itself and 1. No other number should divide it. Means it should not have factors other than 1 and itself. We call it as prime number. Prime number is a number which should not have factors other than 1 and itself. And then composite number means it will have factor other than 1 and itself. Means it's not a prime number. Any composite number you can write it in terms of what? Product of primes. And decomposition is unique. Let me focus on this because this is the topic which you should be thorough with. ಯಾವುದೇ ನಂಬರ್ ಕೊಟ್ಟಿದ್ರು ಅದನ್ನು ನೀವು ಪ್ರೈಮ್ ನಂಬರ್ ಆಗಿ ಫ್ಯಾಕ್ಟರೈಸ್ ಮಾಡಿ ಬರಿಬೋದು. ಅದನ್ನು ಕೆನೋನಿಕಲ್ ಫಾರ್ಮ್ ಅಂತೀವಿ. ಐ ವಿಲ್ ಟೇಕ್ ಒನ್ ಮೋರ್ ಎಕ್ಸಾಂಪಲ್ ಟು ಮೇಕ್ ದ ಪ್ರಾಸೆಸ್ ಕ್ಲಿಯರ್. ಸೊ tell me any number which is composite number. Composite number andre enu? A number which is not a prime number. Andre enu? A number which is divisible by other number other than 1 and itself. I'll take 60. Is 60 composite number? Is 60 composite number? Now I'll write this in canonical form, or I'll write this as prime factorization. So now 60. First start by dividing with prime number. I'll start with 2. 2 3s are 0. Again it is divisible by 2. 2 1s are 5. But this is not divisible by 2. So I'll start with 3. 3 1s are 3 5s are. This is divisible by 5 5 1s are. Can I write? So now the 60 can be written as, count the 2's. How many 2's are there? 2. 2 power 2 into 3 power, how many 3's are there? 1 into 5 power 1. So this is canonical form. Means writing the composite number as product of prime numbers or prime factors. 2 3 5 are the factors. 2 appeared 2 times, so 2 power 2. 5 appeared 1 time, 5 power 1, 3 power. So in ascending order I have written. Any number, any composite number can be expressed in the form of product of, we can write it and express it as product of primes. And this decomposition is unique. Means you will get only one form. You will not get again 2 cube 3 power something. So once we got, this is fixed. You will not have more than one form. That's why we say unique. Then means 2 power 3 power 5 power will be same. You cannot write in any other form. It's a conclusion. You should know what is a prime number. You should know what is a composite number. You should know what is a divisor. What is a prime number? A number which is divisible by 1 and itself, and no other number should be able to divide it. Means it should not have any other factor other than 1 and itself. It is prime number. Example 3, 7, 11, 2 is also prime number. 7 is also prime number because it does not have any factors other than itself and 1. 11 is a prime number. 11 is divisible by 1 and 11. No other number can divide. 19 is a prime number. And what are composite numbers? Numbers which are not prime numbers are composite numbers. What are composite numbers? They should not be prime numbers. They should not be prime numbers means what? They should have factors other than 1 and itself. If I take 15, 15 is not a prime number because 15 is divisible by 3 and 5. Which 15, if I take 15, it's not divisible by only itself and 1. 1 and itself alone divide agata. Along with that, it is also divisible by 3 and 5. So this is also prime number. Now any composite number, if I give any composite number, you can express it as product of prime factors. 2, 3, 5 are the prime factors. Yes. Factor means what? Which will divide the given number. 2 will divide, 3 will divide, 5 will divide. So these are the factors. Prime factor means what? They should be prime numbers. 2, 3, 5 are prime numbers because they are divisible by 1 and itself. They are not divisible by any other numbers. Do you agree or not? So I hope all of you understood fundamental theorem. So next, this is the concept. If I give any number, you should be able to tell number of divisors and you should be able to tell sum of divisors. And for that, first we should write in canonical form. They will give a number, write it in what form? Canonical form. Canonical form means what? Prime number power factor. P1 alpha 1 into, this is a given number n. I can write it as P1 alpha 1, P2 alpha 2, P3 alpha 3, so on. Pn alpha n. So P1, P2, P3 are any prime numbers. Alphas are their powers. So if you add 1 for the power, 1 plus alpha 1 into 1 plus alpha 2, so on, if you do, you will get total number of primes. And if you use this formula, you will get sum. Don't worry about these two. These two are the topics of discussion for my next session. So if you attend my next session, two important questions for board exam also you will be learning, and you will be learning the process. But now I gave a brief introduction about the chapter. The chapter is what? Number theory. So first you should be aware of number systems, natural numbers, whole numbers, integers, rational, irrational, real, complex, all those things we will be studying. But in today's class I taught you only natural numbers, whole numbers, integers. Then I taught you prime number, composite number, and basic concept or important concept in today's session is writing the composite number as product of prime factors. Writing the composite number as product of prime factor, we call it as canonical form. Once you are thorough with this, this is the concept we are going to study in my next session. Just I gave a plain approach here, but when I take numbers, I'll make you understand what is this. Got it? So please watch this session. Please learn the definition of numbers and know what is canonical form. The real class and problems approach will start in my next session. Thanks for attending the session. I'll see you in my next class. Thank you.